Okay, well, let us get started. I think we have enough people. So today we're going to go through our after-sale organization, the online support tickets, the RMA process, troubleshooting for the hybrids, on-grids, and some of our monitoring devices. So first of all, we do have FAQs, especially for the GoodWe Plus. Sometimes there are a lot of questions regarding GoodWe Plus and how do I create an installer account and all these different questions. So on the GoodWe Plus section, you'll find an FAQ that gives us a lot of questions and answers already. So should you have any questions about the GoodWe Plus program or anything about that, when will you get your results and all of that, most of the questions and answers are already there for you on the GoodWe Plus website. But should you have any other queries that aren't answered by this FAQ, feel free to contact the support teams for your region. That will be your normal service teams as per your region. Then our after sales. So we've got competent local technicians. We do remote troubleshooting and commissioning support in almost all the languages. We are supported by the level 2 engineers and technical managers, such as myself, all in the EU time zones. With flexible resources with service partners to adapt to our growth. And we also have the quality control by the unified ticket and phone systems across the EMEA to track the KPIs. So we are KPI driven, so we always try and focus to improve our response time, as you can see. So here's a nice overview of the after-sale service offered by GoodWe Europe. You'll see we are in most of the countries in Europe. We do have dedicated service teams all over and support local languages, and we are constantly expanding as required. How to contact our technical support. So you can also find this on our website. So you can go to support.goodwe.com. I'll show you now where you can create tickets, or you can contact our support lines on the telephone numbers, or send them an email, which will also create a ticket in return. So how do our after-sales service process works? So first we have a query by one of our customers, either through the technical hotline or online ticketing system in all the 9 local languages. Thereafter, we do troubleshooting to see whether we can resolve the issue remotely. Should there be anything more serious, then it gets raised up to the 2nd level. Thereafter, we can determine whether something needs to be replaced or not. Then we do our RMA process where we help fill out the form and we double check that and everything. Then we ship out a replacement product. The product replacement is then done on site by the installer in 99% of the cases. Then thereafter, the defective device is returned to us, so we collect it within 15 days of replacing the inverter. We thereafter inspect and test the device to confirm that it is indeed an RMA, and then we confirm the warranty of the device. So now we have our online support tickets. So created tickets get appointed to the correct support team to avoid delays. So sometimes if you just email support@goodwe.com, that's our general global email address. That will then go into a pool, which then needs to be manually assigned by one of our customer agents after asking already from you some more information about your device and what location, where you are in the world, so they can assign it to the correct team. So it's always important to make sure you either create it on the website or send it to the correct email address. So the tickets, it's ideally to have one account which accesses all the tickets from within your organization, so you can manage all the cases, and all the tickets are visible from one account, giving you the maximum transparency for your organization. So I always recommend it's better to create and send tickets and follow up on tickets on the support website. Unfortunately, very often email filters and spam filters might block a reply from us, especially if there's any attachments or things like that. So it's always recommended to use support.goodwe.com. There you can also track and keep an eye on all the cases that you might have open. So on support.goodwe.com, you can simply sign up with a name and email address, and then they send you an email for confirmation. After receiving the email, you accept the confirmation and set up the password for your account. Then before you submit a ticket, you'll see, we've got lots of FAQs and fault finding. So for all the different reasons, problems you could be experiencing, you can always come and search in the knowledge base. So I'll see our knowledge base has all the FAQs where you can come and search for the problem you're experiencing. Next, you can go to as you'll see, let me just show you in the slide here, you'll see my area. So under my area, you can add a ticket, and as well as look at all the existing tickets that you have available. Yeah, you'll see it asks you some information like, are you an installer, distributor, or end user? Select the region, which is very important, so it gets allocated to the correct service team. Most important for us is the serial number. If we have the serial number, we can immediately have a look at the data of the device to see exactly what's going on to efficiently support you. So that's the most important information we need. Very important is the region, so it gets assigned to the correct team, so there's no delays in your service. And then the serial number is the most important, so we can immediately action and help to see what the problem could be. Otherwise, our first response is, good day, so please provide us your serial number. And that just adds unnecessary delays in the support. The next, communication mode, just to know if you are using LAN or Wi-Fi, especially if it is pertaining to any communication issues. If there's no communication issues, you can leave it out. Then just a brief subject of the product, problem that you're experiencing, just for easy view, and then the detailed description. So in the detailed description, please provide as much information as possible. If you've done fault finding or anything like that, always try and encourage, if you have a problem and you see on the SEMS portal there's a problem, create a ticket so our team can look at it and advise you before you go to site, so that they can advise you how to resolve it. So obviously first you can check the FAQs. If there's nothing there, you can create a ticket for our support team to advise you on what to do, or they might be able to resolve it remotely without you going to site. But if you do go to site and you do some testing or anything like that, take photos, take videos, as much information as possible. The more you can provide us on the initial creation of the ticket, the quicker and more efficient we can help you resolve the issue. Now, once your ticket's created, you'll see in my area, you can see your tickets, the ones that are open, closed, or on hold. An email will be sent to you if there's any change in status in your ticket. So whether it's registered, closed, or changed to on hold or anything like that, or when GoodWe support team sends you a message. So you always receive an email from us. As I say, please always use the web browser, especially if you are requesting firmware files or anything like that. Unfortunately, mailboxes generally will block those types of files. But you'll always find the reply on the web version. So when replying back to a ticket, you can do it in two ways. So from my area, you open the ticket, you'll see there's a reply function, much like any mailbox on emails. There you can reply to the ticket, or you can simply reply to the email that you received. It's always advisable to reply on the same ticket, but if you should experience something new, please create a new ticket and not reply on an old ticket. Because if you reply on an old ticket, either it might be blocked or it will reopen an old ticket. Now we must work on a very old ticket, and that unfortunately reflects very badly on the KPIs of our guys. So please, always, if your issue's been resolved over time, don't look for the email in your email box from the ticketing system and reply to that. Please either send a new email to the correct support email address, not the auto reply email address there, or create a new ticket on the web page. Even if it is the same device, you can just create a new ticket because it is a new problem that's occurring. Then our RMA process. So for those who aren't aware, the RMA stands Return Material Authorization. So it's the formal process for the repair or exchange of products. So we'll only take into account a properly filled out RMA form. Most of our service teams will assist with the majority of the information which you require in this form, but we do always require the mandatory fields as the customer address, the delivery address, and all those kind of things, so we know where to ship a replacement product and we don't have to ask you for that. So normally our teams will send this to you. The most important information is the top, where we need the name and the contact details, as well as the delivery address for any replacement products that need to be sent. The product serial number is also very important for us to have. Most of the time our service team will have that. So they'll generally ask you to fill out your name, the address, the shipment address, serial number, installation dates, just that very basic information. If there is testing or anything you have done yourself on site, you're more than welcome to fill that in for us. If the team has not requested it yet, your MPPT, so what's pertaining to the fault that you have, how many modules you connected per MPPT, anything like that, if we are having a string or a production related query. But most of it, our service guys will help you to fill out the required information pertaining to the fault that you are experiencing. We also have a form for the hybrids and the on-grids, very similar. The hybrid just has an extra section for the batteries. And please, if you do go to site, if you do any testing or anything like that, please record it with pictures. That just helps us to speed up the process. So you can, if you have those pictures, you can just email them to our service teams. They will add into the form, and they'll always be available in the service ticket so that we can have a look at them when we are approving the RMA. I think we can actually, have not sent you the link yet for the questionnaires. We can maybe send that link to everyone quickly. So we can actually go through some of the questions. I'll just pull that up in front of you so everyone can click on the link below, where you can fill out your email address. So there's just a few general questions. Which of the phone do you use at least once a week? How many people is in your service department or own department? So they're just very basic general questions. Next we'll go through the questionnaire. So first, in how many languages does GoodWe offer technical support? That one should be fairly easy. Second, where is the EU head office located? So as you'll see in our pages, the head office is always first. Question number 3. How is the customer notified if the ticket status is changed? There's only one way we notify customers. Question number 4. In which section of the ticketing system can the articles or FAQ be found? And then question number 5. What is the most important information to provide when submitting a support ticket? So that should be fairly simple. I'll just give you guys another few minutes to work on that, and then we'll continue on with the rest of the webinar. And we can continue. We can also answer the rest of those questions as we are going on. So hybrids, the troubleshooting of hybrids. So hybrids are much more complex, and as you'll see, these 6 perspectives we can look at to do the fault finding of the device. So it has a lot more aspects to look at. So the modules, the batteries, the utility, the smart meters, the monitoring platform, or the inverter itself. So when troubleshooting the hybrids, where do we begin? So we'll go through the tools required for diagnosis, some of the recommended tools, how to remote diagnosis with SEMS Portal, where and what we can look for, and then lastly the on-site inspection with the inverter LEDs as well as PV Master. So this is just some basic tools that we recommend one could have on hand for any PV system. Very same for the on-grids as well. So insulation tester to make sure the insulation of your PV modules, DC power supply, not so vital for the hybrids, but more for the on-grid inverters that only power on DC, and then your general tools that everyone should have. So the first steps I will do with a live demo. So as you can see in the SEMS portal, with an installer account, you'll see you've got plant, alarms, reports, and management. So the alarms page is an extra page that you can see from an installer's account. Here you'll see any errors that might be happening on any of your plants. You can also change this to recovered or to view. You also have a search function to search specifically the device. Especially once you have 100, 200, 300, 400 installations, searching will probably be the best way to see whether there's a recorded error for any of your customers. As you'll see here, there's details which you can click on. That opens a detailed page. So in here, we also do have a bit of a FAQ and possible things that could be resulting exactly what's happening on the device. As you'll see, majority here, you see the VAC failure. That's most of the time, that's why we have hybrids in many countries, to have power when the grid fails. But you'll see there's possible reasons why it happened and troubleshooting. You can also go to history curve to download the history of this under the reports section. So history curve will take you straight into the report section to download that history curve. As you'll see in the presentation, I do have that screen there for you to see. So as you see, I went to history curve, it automatically selected this device for us. We can then select what data exactly we want to have a look at, either in an Excel spreadsheet or a curve. When you select curve, we can select 2 units, so voltage and current. You can select multiple voltages and multiple currents, as long as it's voltage and current. And then you can export that. In a curve, it will show you a nice graph of that information. Sorry about this. My Zoom won't let me select the top of my browser. Then next we have the plants. So when we write diagnosing any faults, our plant itself can also give us a lot of information. Normally, it can give us a status, whether it's working, fault, or anything like that. We have our battery SOC here. As you'll see, the SOC is here as well. But when we have multiple batteries or multiple inverters with batteries on a plant, it won't display in this graph the battery SOC, but we can see the overall battery SOC here, as well as open another graph to view the battery SOC graph. Next, you'll see there's a lot of important information here down for us. First of all, for the hybrids, when a plant is set to battery storage, as you can see here, battery storage, then we get this nice energy flow diagram. So this shows us the PV modules, the batteries, the home, as well as the utility usage. But when we go in to look for a problem, to dive a bit deeper into what the problem is, we can come here. So here we can see the device model number, the serial number for the device, a lot of different information, the internal temperature, the output to the utility, the output to the backup output, as well as utility voltage and backup voltage. We can see the PV voltages for all the strings connected to the inverter. You can see the battery information, so the voltage of the battery, the current draw, the wattage draw or charge, the status, whether it's charging, discharging, or in a fault mode, if there's any problem with the battery, BMS warnings, so what is the BMS telling the inverter, as well as the charge current limits from the BMS. So these charge current limits are dynamic from your VMS. So if you aren't seeing a value here that you are expecting, especially on low voltages, you'll see the current will increase quite a bit depending on the modules you add to the inverter. So you can always double check to see that your charge and discharge current limit is correct, because as we know, our maximum charge and discharge power is always going to be the voltage times the current, which gives our maximum charge or discharge power. And then lastly, the state of health of the battery and the inverter firmware version. Normally the last two digits is ARM firmware, and the digits ahead of that is DSP. Just a bit of information, it's not vital for you to remember. But then we want to look at more detailed information. We don't just want this big overall graph. Yeah, we can go, we can see the breakdown, you can see the individual voltages of the MPPTs, the currents of the MPPTs, the voltage of the AC. You'll see there is a lot, P meter to see the combined power meter. On the three-phase, we'll have a lot closer to the bottom, you'll have P meter 1, P meter 2, P meter 3 to see the individual meter data. We'll show that a bit later with fault finding. Power backup to see what the power is and what loads are running on the backup output of the inverter, especially if you're having tripping issues or anything like that. So yeah, here's where you can see all the breakdown of the information to fault find to see exactly what's happening with your systems. And should you not see anything here pertaining to fault, you can then contact our service teams to have a look at the back end to see what could be the problem. The next is the on-site troubleshooting. So if you do go on site, or if the end user is on site and they say they're experiencing a problem, the first place one can look is the LEDs on the inverter. Please always reference on the side of the inverter, you'll always find the reference code for what the LEDs indicate on the inverter itself, or you can look at the user manual, which is also available on our website. So very often, I won't go into too much detail into these, but based on the fault that you're experiencing, there's different indicators that it could tell us. So especially Wi-Fi, if there is any problem with the Wi-Fi, one of the first things our service might ask you is, what does the Wi-Fi LED indicate? So obviously, if there's a problem with the Wi-Fi, we cannot look from our side to see what the problem is. We'd have to have a look at the Wi-Fi indicator to give us a good idea of what the problem would be. But as I say, you'll see all of this is on the side of the inverter or in the user manual to describe what each LED means, because each different model has different meanings for the LEDs. Next, on site. So if you have gone on site now to go and see and help the customer to see what's wrong, we can connect to PV Master to the device. So if there should have been any alarms or anything like that, let's see, when you open PV Master, we're in the overview. So here we can just see the general running status, the work mode, and the status of the BMS, the smart meter, and all of that. Next, you go to parameters. So parameters at the bottom, it will start in the data tab. You then go to alarms. So you go to parameters and then alarms. Here you'll see the last 100 recorded alarms. So the last 100 recorded alarms, will be it a BMS alarm, an inverter, all the alarms will be listed here. Sometimes there are alarms that might not appear here, especially if it's a sudden fault or sudden shutdown where the device hadn't had a time to log the alarm, but very often we can see this on the back end. But yeah, for the most part, you'll see the alarms and it will tell you exactly what's going on. So it'll tell you the fault description is the fault, what it could be. So utility loss, VAC, FAC failure. So the grid went off in most instances. Which mode the inverter is in. The type of error, is it the error, is it the warning? and then the date and time of the error, as well as the fault code. So if you go on site and you have looked at this, just take a screenshot before you make your support ticket, then you can just send it to us on the support ticket as well. That just gives us a faster access to look at the exact date and time of the problem you experienced. Next is diagnose message. This very often gets confused with error messages. Diagnose message is not an alarm or an error. It's simply the logic operating messages. Most of it is, I am doing this because of this. I am not charging the batteries because the batteries are full. In this example, you say effective battery discharge current limited by BMS is low, so the battery is flat. Battery doesn't charge because there's no smart meter connected. So it's basically just logic messages. It's not any error messages. We get very often support tickets saying, my inverter is giving all these error messages, but it's just diagnose message. It's basically just logic. The inverter logic saying, I'm doing X because of Y. And a lot of them don't make very much sense. So I wouldn't worry too much about it. We very rarely use diagnose message. If our service team needs to use it, we'll access it from the backend. So we look at some of the common errors for hybrids. Please note some of the more technical questions. So if you guys are asking very technical questions, I'll try and answer them as soon as we are done with a section. Then I'll go through the answers for those technical questions. So one of the most common errors we have on the backup output is the backup shutdown. So for this, we need to confirm the peak load demand on the backup output. As I showed you in the example in CMS Portal, you can go there to see regularly what the customer's loads are. Very often the customer will have higher loads when the utility is on, and when the utility is off, they are limited by the discharge current. As I mentioned earlier, we always have a look at this discharge current limit. So this discharge current limit here. As you'll see, this is a low voltage 48 volt nominal system at 74 amps, so we can know that's roughly 3.4 kilowatts that the customer can run on this inverter. So should it exceed that when the grid's available, it's fine, but when there's only batteries available, the inverter will shut down when we're exceeding the discharge current limit of the batteries. Also, next we can confirm the SOC limits. So sometimes the SOC limit on the on-grid and off-grid are set incorrectly, and then that can also, the device has reached its set point and it switches off. If that happens, you'll have no error codes, no warnings, nothing of those sort, because the logic says I'm gonna switch off now, so it switches off. It's not a fault, it's a setting. So just double check that these settings are correct. So from the install account, you can also view that remotely. Next, we also have to look at inductive loads. Unfortunately, inductive loads are an inverter's worst enemy. Inductive loads can draw anywhere from 3 to 12 times the rated power output on startup, based on the age of the load. Fridges, freezers, newer ones, you have very little problem with. As they get old, as they age, as capacitors get older on the devices, the windings get older, the current draw on startup generally increases greatly, and those can overload inverters in an off-grid scenario. So it's always, very often it's going to run, no problem, but the wrong inductive load, especially water pumps, cheaper water pumps and things like those, tend to have a very high inrush current because they are starting against a higher head pressure, and that can cause an overload. So sometimes if you do have loads like that, you might require a soft starter or motor starter to mitigate any startup current. And then lastly, you need to ensure that you do have batteries. Our devices, our hybrids, do work without batteries. You can just use it as a normal on-grid grid-type inverter, just connecting PV while you wait for stock of batteries to come back into your country. the device does work. Just recommended don't connect your backup loads to the device while there are no batteries. The backup output will be on when the grid is there, and it will give a little bit of power when there's PV, but if you have any oscillating loads or any change of loads, it will trip off because you cannot have stable output without batteries. Here's an example, as I showed in SEMS portal. This customer has a 4.6 kilowatt ES inverter. As we can see, he peaked well over 4.6 kilowatts, and then we can see the dip down to 0. So that's an overload while the grid is available. The device was overloaded and it shut down. And after a little bit of time, it started back up again. So that's a clear indicator of an overload on the backup. However, when the grid is not available, the overload time is generally a lot shorter. So with the grid available, we can overload up to 6.9 kilowatts, and it's dynamically. So if it's only 4.8, 5 kilowatts, it might allow it to run for an extended period of time, as this one probably ran for a minute or two before it shut down at 5.5. But when you only have batteries and we're limited to battery discharge current, we cannot over discharge the batteries. So for the battery safety, so the batteries don't shut off or anything like that, we normally switch off quicker. And because of that quick shutdown, you don't always see the overloads. But on the back end, we can have a look and just get a message that says what the overload is. So this customer had less batteries. We do see higher spikes, but on the back end, we can see that it did report an overload error. So next, very common is phase order fault. As you'll see when you look at alarms, you'll see the fault code 16384. That's phase order fault. Sometimes the utility may change something, go and work on their transformer and restructure it, especially in a country where all the homes are single phase. In Africa, this happens often because it's single phase. All the homes are single phase. Changing the phase order doesn't really affect anyone, but it can affect the three-phase inverters because they are sensitive to phase rotation to make sure that anything on the output has the correct phase rotation. So normally you'll see it stuck in a fault mode. SEMS portal might report this as VAC FAC failure, but you can always see the fault code on side as that 16384. That is phase order fault. So normally to resolve that, we just switch L2 and L3 on the AC terminals. It's always advised to do this on the utility side as far as possible, under the main incoming breaker from the utility. That way it changes everything on the smart meter as well, because you'll see next in our meter fault finding steps, sometimes fixing the phase order fault creates a smart meter fault because we're swapping the phases on the inverter. We need to then swap it under the smart meter and swap the CTs around to the correct phases as well. That's just one thing to keep in mind when you do have this problem, that you need to swap everything as well as the CTs and the phases under the smart meter. So next, one of the most common things we have is the smart meter installation. So best to look, so when we have no PV or no battery discharge, we can look at the graph. As you'll see, we have constant export at night. Obviously, if you can see, there's no DC power being used, so we shouldn't be exporting. That's a good indication that the CTs are connected incorrectly. As well as for our hybrids, you'll see the batteries stay full all the time. They do not discharge because it has the logic as if we see something exporting, we use that export to charge the batteries. Also, if you're using zero export, you'll have very low PV production, as you'll see in this example. And the load profile does not make any sense. As you'll see at night, our load is 0 because it's being negated by the meter readings. So here's an example. as I said, with the phase order fault. So this is a 3-phase system. This customer set it to 0 export, so they're not allowed to export to the utility because they will be billed where they are exporting. Yet we can see on the main graph, we see there is quite a bit of export happening, although it's set to 0 export. But this, because we have our ETs, they do have the unbalanced output, so it's set to unbalanced output. So first I went to find the meter phase 2 was showing all our export. So then I went to look at IAC2. So IAC2, there's no notable AC output from the inverter on IAC2, but I found on IAC3 that export is on IAC3. So what this means is our smart meter thinks it's on AC2, so that's why IAC2 is not producing anything, but it detects usage on phase 3. So phase 3, it's producing as much as it can, but it can't negate that usage, and this results in export because it reads the export on phase 2, but it's producing it on phase 3. So that's why it's very important to make sure that the phases on the smart meter match the phases on the inverter, especially if you are using the unbalanced output. If you're not using the unbalanced output, you wouldn't have this problem. But for the countries with 0 export, unbalanced output is the best way to get the most production. So it's always advisable to make sure that your voltage sense and your CTs match exactly the inverter's input. So next, the smart meter test. Very often the smart meter test does fail or it gives us incorrect results. The causes for this could be, so we need to make sure that we are consuming power from the utility. So at least 150 watts per phase. It's always recommended maybe to switch your PV off and put on as many loads as you can to make sure that we are consuming from the utility. If you then run the meter test, while we can see a lot of consumption from utility on all our phases, then the meter test should be able to be performed accurately. If there's a problem with the BMS communication, if the BMS is not connected correctly or there's anything like that, the meter test can fail as well because it tests the BMS communication as well as the meter communication. Sometimes the meter might not be wired up correctly. It would generally say CT connection fault or CT reversed or anything like that. But like I say, you can always double check on SEMS portal as well to see whether everything looks correct. Like I say, the B meter phase 1, phase 2, phase 3. Normally you'll install a little bit before, then you can connect it online to the SEMS portal and then go and view that everything is correct there. So lastly, if we aren't detecting the smart meter, so if you see on PV Master it's saying communication failed to the smart meter, it could be that cable because the cable's already fixed to the inverter. Sometimes routing it or running it does cause an issue. Sometimes customers will extend that cable. If you extend it, I always recommend it, replace the entire cable. Do not use the RJ45 connector to male to female to connect them to an external cable. That always causes problems. It's an extra point for interference. If you replace the smart meter cable because the customer's utility box is further than 15 meters from the inverter, replace the entire cable. It's normally just a few screws under the inverter, 4 little screws. You open the cover, put in a new cable, crimp an RJ45, and run the whole new cable all the way. So please don't use an extender or anything like that because it does cause extra interference. And lastly, there's always a possibility that the smart meter is damaged. Very seldom do we get smart meters that are faulty. More often than not, 99% of the time, it is a wiring mistake or something like that. So meter placement is very, very important. So the meter needs to measure the flow to and from the grid. So it's very important that we put our CTs on the correct place. So we never install the CTs under the inverter, never install the CTs between the inverter and the loads. We must make sure to always install the CTs between the utility and the entire property. So it must be able to read the loads as well as the inverter's production. So as close as possible to the utility meter is always recommended, or the main input cables from the utility into the home or building. The next, as you'll see on all of our CTs, we have an arrow which says K to L. So L is not load. Some people confused L with load. So it's house to grid. So the arrow must always be pointing towards the utility supply, not towards the loads. And in all my years, I've never had a sticker incorrect. So please pay attention, the stickers should always be correct. You'll see it's the same for our three phase. It's just repetitive, repeat, rinse and repeat. As you'll see, we references over and over and over again, because it is very important to remember it's always K to L. The arrow points towards the grid from K to L. Next, we look at the CT wiring. So the CTs all come pre-wired on our smart meters, but very often due to placement, the customer's utility board is full. You have to install an external board to put the smart meter in, although it's a nice only 2 DIN space. Very often you have to loosen the cables on top to route the wires through from the one board to the other board. Please pay careful attention to this wiring. As I said, we've never had a sticker incorrect, but if you swap the wiring around here, the sticker will be seen as incorrect because it is wired incorrectly. Please also notice here, A is 7 and 8, B is 6 and 7, C is 3 and 4. So phase 1, phase 2, phase 3. This is from right to left. So please, the wiring is on the side of the smart meter as well as the user manual of the inverter and the user manuals of the smart meters, which can be found on our website. So if you have to remove these cables to route them into a different box, please pay very careful attention to that to make sure you connect them correctly, because this incorrect connection is a nightmare for fault finding. So as you'll see, CBA. So it's reversed. So please always make sure that this is 100% correct. Next, which is vitally important, is the voltage sense. So the voltage sense, as you'll see under the smart meter, is in a more logical order. So it is from left to right, A, B, C. So as you'll see, phase 1 is entering here, but phase 1 CT is over there. So please pay careful attention to installing this. The voltage sense, it's vitally important that the correct CT is in the correct direction with the correct voltage input. If you swap the voltages around, that CT will see all the current out of step, so it's out of phase, and then it will see it as a reversed value. So always make sure that the correct voltage sense to the correct CT is connected. It's very important, very important that this is 100% correct for the 3-phase installations. And as I said, if you change the phases on the inverter for a phase rotation error, then you're going to have to change the phases yeah as well as swap the CTs around. So just pay careful attention to that. So next, the smart meter. So especially for the on-grid, so if you're installing a smart meter just to power control one single on-grid inverter, you have to use the LEDs on the smart meter to make sure whether that's correct or not. So obviously the top one must be on, which means it's powered on. Blue is the energy flow. So if it's solid, we're consuming from the utility. So we should see solid when there's just a smart meter connected and no inverter. We should see that LED is solid. If it is flashing, it means we are exporting. So if you only have the smart meter powered on and you see it flashing, then there's definitely a wiring mistake on the smart meter. And then lastly is the communications LED, which is communications to the inverter. So if it is steadily flashing, it's transmitting data to our inverter. If it blinks 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, that's only when this reset button is pressed. So you should never really see that. So part and parcel with the smart meter test unsuccessful. As you'll see, some of the inverters also give us indications on the LEDs, as well as that LED of the smart meter there. Next, we have abnormal charge and discharge of the batteries. So depending on the settings, as you'll see, charging at night, things like that. So we can run PV Master and do the meter test to see whether everything is correct. We can check the economical mode time settings. So if we have set charge and discharge times, that can also explain the reason why we're charging and discharging at strange times. Switch off the supply to the smart meter and observe the COM LED on the inverter will start to blink for some of the inverters. And you can also test the communication cables. As you see here, some examples of unexpected battery behavior. So like this one, the battery doesn't really discharge, and it does not charge either. It just stays more or less in a full charging discharging state. And the battery charge off the utility and feeds into the utility. As you'll see here, this is a very, very odd pattern. So first thing can be our CTs are incorrect. So if the CTs of the smart meter is incorrect, that will also result in strange battery behavior, or the smart meter may not be connected in the correct place. So that does sometimes happen as well. We're not actually reading all the utility. We are reading just the loads, and when the inverter feeds to the loads, then it sees it as export, and then it starts to charge the batteries again. So we need to make sure that smart meter CTs are in the correct place. Sometimes it can be incorrect settings on PV Master. As much as we don't want our end users to play around with the settings, sometimes they Google and then they play around with the settings and can cause a little bit of havoc sometimes. But it's very, very rare for that to happen. But from your installer on the SEMS portal app, you can go in and verify the work mode settings and things like that. If the battery SOC is very low, especially in European countries where you have a lot of snow or bad weather for a very long period of time, when the batteries get to a very, very low percentage, it will automatically recover charge and will charge the batteries up to a safe level, and then it will continue normal operation. So that is quite normal to see. So if it is just a little bit, as you'll see in this slide, so if it is just a few percent, as you'll see, it's between 6 and 12%. This normally can be attributed to that safety recharge. You just charge the batteries up a bit to make sure they are in a safe state. So this also depends on what batteries you have. Very often, if your loads are less than 50 watts per night, per phase as well at night, the batteries won't discharge to cover those, especially if you are using zero export We always try and keep the positive draw from the utility to make sure no battery power is exported to the utility. If there's a smart meter communication error, we'll also have an issue, as well as if there is a BMS communication error, we might see some strange behavior as well. This is a condition that happens sometimes. So if we are no backup with a cold start on inverters, so especially the low volt inverters sometimes are used on sites that don't currently have utility. We always need to make sure that this grounding is correct. So even if there is no utility, as you'll see in this picture here, we need to make sure that there is grounding. So if obviously there's no utility, a ground or earth spike needs to be installed to make sure we have grounding. This is a safety regulation in most countries, but the inverter does require this to check that everything is correct. If there is no grounding on the site, your device may not start up, it will just remain in a waiting mode. This is a very small use case, but it is something we have encountered, especially on the EM and ES devices, where customers install them without utility, and the devices do not start because there's no ground connected. So we need to make sure that there is always a good grounding connection. So then we can go through to the next round of questions. So if you've been answering them, I'll just go through them quickly to just give some hints. But if you've been answering them as we've gone, then you'll be ahead of all of us. So if the ET inverter is stuck in fault mode due to incorrect phase rotation, what is most likely the root cause? So this one should be quite simple. On the CT, the following is written K to L. To which side should the arrow point when installing? So the arrow always points towards the question number 3, where should the meters be installed? Next question, which is slightly more complex. With a 3-phase smart meter, how is the voltage sensed and meters wired? This question is here because it is vital for all of us to know this. So how is the voltage sensed and the CTs wired? So as we can see, the CTs, the first one is on the right hand side and the voltage is on the left hand side. Next question, where can you view faults that have occurred on your system with PV Master? So we know it's not diagnose message, it's not settings, and it is not Wi-Fi diagnose. Let me just answer some of the questions in the Q&A while we go. How do we get the latest firmware versions for our inverter? Please contact your support teams that can help you with that. For the hybrids that have the new Bluetooth, there is an option to use Bluetooth to update it yourself. But for the rest of the devices, to get the latest firmware, you can just contact our support team. They can update them remotely for you. So for PV Master, install a code. That's your installer password, which is GoodWe 2010. It's been the password since 2010. Let's keep going. Taking a bit long today. So the same basic tools. DC power supply does come much more handy for the on-grid inverters, since most of them only power up from DC power unless they have optional AC extras. It's always good to do preliminary checks, although our inverters do have reverse polarity protection. It's always best not to put it to the test and check these strings correctly to make sure our strings are correct, as well as the AC wiring. And always remember, most of our devices have a DC switch underneath that needs to be turned on for it to see the DC. So here we have a very common error, which is isolation fault or ground I fail. So it's the insulation resistance between the ground and the modules are too low. So first thing to do with an error like this is test the modules. So the PV modules may have a short circuit, so that the insulation of the PV current to ground is no longer correct. We need to measure the resistance between the module frame and the metal bracket. So if the ground resistance is less or equal to 10 ohms, then the ground is good. If it's greater than 10 ohms, then the grounding is incorrect. We need to check whether the error message is displayed. So we can check our strings one by one, remove all the strings from the inverter, connect one string up to the inverter, see if the error is still there on one single string. We try a different MPPT as well to see whether it appears on one MPPT but not the other MPPT. So with one string at a time, we can test that. So if there is an isolation fault on one specific string, we can find it in that way, which string it's on, and then we can do all the fault finding of that string. If we get no results by doing one string by one, we can also use a DC power supply. So if you start up an inverter with a DC power supply, if it still gives an isolation error, then obviously the inverter is at fault. But if the inverter still starts up and works fine, we can measure also the impedance of the AC neutral to ground, and this should be less than 10 ohms, and a voltage of less than 10 ohms if you measure the voltage, 10 volts, sorry. If the problem still persists, create a support ticket, provide all the information of your fault finding so that we can replace the device for you. Next is utility loss. So utility loss is obviously the inverter is not seeing any utility power on the inverter itself. So we can check if the circuit breaker or current leakage device is on. We can disconnect the AC terminal and measure the voltage on the connector to see whether the voltage is correct under the connector. We can check live, neutral, and earth are properly connected under the inverter as well, and also measure the impedance between live and neutral on the inverter. So once you've disconnected the ground, so it should be greater than 200 kilo ohms, then the connection between live and neutral on the grid side is correct. If it's less than 200 kilo ohms, then please contact support for us to assist you. VAC fail, very similar to utility fail, but it is a voltage error. So we're saying the voltage is incorrect. So sometimes you'll see this when the grid is off as well. You'll see VAC failure. But if the voltage is out of operating range, we will also get the VAC failure. So we can change the country safety code to 50 Hertz default, which is a wider input code. It's less strict than most safety countries. And then we use this for the test purpose. So if we put it to 50 Hertz and it operates correctly, then there could be an error on the utility side that you'll have to address with the utility company to rectify. We can check the AC cables are properly connected, that there's no hot connections, and that then make sure they are torqued properly. Then if measured the value between neutral and earth, the voltage is greater than 10 volts, then it can indicate that there is poor grounding or poor neutral connection on the inverter itself. If the voltage rises on the AC side, so if the inverter starts to produce, you see it works, VAC failure. And when you restart it, it does exactly the same. You'll see that the AC voltage is climbing as soon as the inverter starts to produce. That could be the impedance of the cable from the inverter to the utility might have a high impedance, and that then results in a voltage climb by the inverter side, and then the inverter trips off on VAC failure. So as soon as the PV starts producing, you will have an increase of voltage. And that could lead to the inverter switching off and VAC failure. Sometimes it's a bad cable with a bad connection in the cable, which has a higher impedance. And obviously, if none of this resolves the issues, please create a support ticket. Next, FAZ failure, it's the frequency of the utility. So you can see that the frequency is within your country regulations as well. Same the voltage between neutral and earth, just make sure that is correctly connected. And lastly, if it still persists, please contact support. Then next we have wait mode. So a lot of time our on-grid inverters will sit in a wait mode. Same also goes for the ET+. A lot of the inverters like the XS series, the STT-G2 and SMT, as well as the MT series and the ET+, all have external connectors. So the ET+, as well as the XS, STT-G2 and SMT, all have these connecting plugs. They will be in the accessory pack, they won't be plugged into the inverter already. Please always just make sure to plug those in when you aren't using any of those functions. Even if you might need it in future, just plug that connector in. Unfortunately, during shipping, we can't always plug those in because they are slightly longer than the device and they have a risk of being damaged. So they will be in the accessory box. So please always make sure to plug any extra accessories in, except obviously MC4s and things like that. But any specific proprietary plugs for the inverters, if you have them in accessories, please don't throw them away or put them in a box somewhere. Install them on the inverter so that everything can work. So all these plugs you'll see have a remote disconnection terminal. So that is a safety thing that is used in some countries. So if it is used in your country but not necessarily on all the installations, when you select your country code, it will enable this feature. If that plug is not plugged in, the inverter will not operate. It will remain in a waiting mode. So we always need to make sure that that is correctly inserted. Next, we have our communication with the Wi-Fi. So what to do if you can't find solar Wi-Fi, if we see solar Wi-Fi but we can't connect to it. If you can connect to solar Wi-Fi but we can't do the configuration via the web address, or the customer has changed his router and now the device can no longer be connected. Then we have to do the Wi-Fi reset. On the older ES and BT inverters, you might find there's a reset. Sorry, this is a mistake. SPP. There's an old reset button on the older devices internally under the meter port. But for all the new devices, we'll all have the newer Wi-Fi modules, the USB type. As you'll see on the module, we do have a reset button on the Wi-Fi module, so no need to press it on the devices. We can simply press it on the Wi-Fi module. I normally recommend press and hold that for 5 to 10 seconds. To make sure we reset it properly, especially if we have to change the root address. If it's just not reconnecting, the customer can just press it for a few seconds. Then it will just restart the module and reconnect to the network. Next, as you'll see, always the best way to the connection is through the 10.10.100.253. Yeah, we have a nice interface, which we can see the customer's RSSI. So RSSI is the signal strength as well as the Wi-Fi channel. So it's always good to come and have a look to see what is the signal strength recorded. As we know, Wi-Fi can be very unstable when there's very low signal strength, or if there is any object such as microwaves, because this is a 2.4G Wi-Fi only. If there is anything like a microwave or something between the access point and the inverter itself, we can see a lot of disconnections, and constant disconnecting might result in it not reconnecting back to the network. So it's always good to make sure that our signal strength is sufficient. What I'd recommend is 50% or above signal strength, just to make sure that interference cannot result in a disconnecting. Next is Wi-Fi LED. So if you do have a look on site, if there's any issues, please always ask the end user, even before you go to site, if they found, say, my inverters off Sims portal. First thing you can do is ask them, what does the Wi-Fi LED or communication LED indicate? That gives us a good indication. So if you phone support, say my Wi-Fi is doing this, the Wi-Fi LED is indicating either 2 flashes or 4 flashes, which is what you most commonly see. Then they'll know how to advise you correctly on to solve the problem. So 2 flashes generally it is not connected. So sometimes it does disconnect from the router. Like I say, if there's too much interference constantly and it cannot reconnect in time, then it might not reconnect back to the customer's network, and then we'll see this 2 flashing. If we see 4 flashing, very often it is a network issue. So 4 flashing means I am connected to the customer's router, but I cannot communicate to the SAMS portal. So that is very often a firewall issue. So unfortunately, the port TCP port 20001 sometimes gets blocked by network firewalls. Any home router has a firewall of varying degrees. Sometimes it might block the communication after 1 week, sometimes it might block the communication after 1 month. Especially if you see the customer does a reset, it works again 1 week or 1 month later, it disconnects again, and then goes back to 4 flashes. That is a clear sign that there is an issue with the firewall blocking the communication. The only way then is to port forward on the router to make sure that is permanently open for the inverter to communicate on. In the past we have found, but this is on installation, you might find it's going 4 flashes immediately. That could also be that we might use an unsupported character in the Wi-Fi name or password. So next is inverters connected to our loggers. So when we connect to your loggers, SC1000 or anything like that, to do power control, export power limit, or any of those other features, we need to make sure we set Modbus addresses on our inverters. Normally you'd see the inverter will also remain in await mode in many of these instances because they are waiting for commands from the logger. Yeah, we just need to make sure to set the communication address correctly on the inverters. So as you'll see on the hybrids, we'll also have this setting. So we always need to set it in range. The hybrid range is 1 to 10. The on-grid range is 1 to 60, because our hybrid SC1000S can only take up to 10 inverters, and the on-grid can take up to 60. So always remember to change that communication address to 1. So your first individual will be number 1, second number 2, and so forth. So then we have EasyLogger Pro, which is, my apologies. So we have ProMate, which is our program for configuring and commissioning our loggers, so the ECC 1000 or the EasyLogger Pro. So that can be found on our website. You can find the download for that under our software on the download section. You'll see there's an EasyLogger Pro or ECC 1000 ProMate. I always recommend using the version 1.10 version of this. Anyone that starts with the version 1 will be the very basic ProMate that will have only the basic required settings for setup. There is others, it's a version 2 that has more advanced communication features for IC 1041 utility controls and things like that. And generally they just make it much more complex to set up because there's nothing there that we actually need to set up for 99.9% of the installations. So just for a very simple setup, use the version 1 ProMate. So once you have ProMate downloaded on your laptop, connect to the EasyLogger. So we're going to use the LAN cable. So from the inverter, from the logger to our laptop, we connect a LAN cable. The loggers are always going to be first in a DHCP mode, so they're made to easily just plug into a network, automatically assign an address. We can configure it via that network, but we then have to use something to find the IP address of that logger. So if you just have a router with just the logger and just your laptop on, it's fairly simple. You don't have to worry about setting it to static. It will be the next logical address. So it should be quite easy to find. But for the most part, we're going to do the direct connection. Then we have to set the logger to a static mode. So on the side, we have a reload button. So you press and hold this reload button. You hold it for approximately 10 seconds. When you let go, you'll see the LEDs will cycle from right to left, as you'll see here, to cycle from right to left. So each LED will go on 1, 2, 3, 4, 5. So you need to see that cycling. If you let go and it goes from left to right, then it means we've not held it long enough. So we need to hold that button down a little bit longer, and we need to see it go from right to left. Then we know we are set into a static mode. Next, we need to configure on our laptop, because we're doing a direct connection. We need to make sure our IP address on the laptop is also a fixed IP address. So that will go under your internet settings, your IPv4 settings. So you can just Google on how to change your IP address for your current operating system on Windows 10, Windows 11. They're all slightly a bit different how to do it. Then you go to your IPv4 settings and you set your IP address. So it's 192.168.1. The easy way of knowing what to do is in the next slide. So ProMate, you'll find the default IP address of the logger. So when you open ProMate, this is already there. So all you do is you make your IP address the same 3 numbers, and then the last number just a different. It can be 201, it can be 1, it can be 100, anything within the logic range that you can set for an IP address, just not 200, because 200 will be the default IP address of the logger. So once you set that, just a standard subnet mask of 255.255.255.0. You don't have to set anything else, you just press OK. And remember, when you're done configuring this, if you're going to use a laptop on a different network, you just have to come back in here and put it on Obtain automatically. So now that we set this, we are plugged in, we just hit the connect button. Then we connect. You'll see it says connection succeeds. This can take anywhere up to 30 seconds. The serial number of a logger will display, as well as the software version of the logger. Yeah, as you see, this is the ProMate 1.1, which is a simplified interface. Generally, we only really need to set anything we need to set is on this first page. We don't need to set anything in power settings because most of this will be configuring over here. So next, if you want to see low data with the SC1000S, we enable this export enable button here. Then we can fill out all the required information below. Thereafter, we can check to see whether our RCTs are working correctly. It's always best to do this with the inverters not powered on. All the inverters can be powered on, just no AC connected to them. So we put on the DC for our inverters. Inverters are on, they're running, they're powered up, but there's no AC connection to them. We leave the breakers or the AC switch off. So we can check our CTs. If you look here in this graph, so at the bottom you see the refresh button. You can press refresh button, then that gives us a snapshot of what we can see from the smart meter. All these values need to be negative. So a negative value indicates consumption from utility. So we need to first make sure we are using correct 5 amp secondary ratio CTs. If the CTs are wrong, we'll also get very strange readings here. But our reading should be aligned. So what you can also do with a clamp meter test, just use your clamp meter, see if it confirms that this is correct. So next, you can also, another test that you can do, which I like doing, is I take the current times the voltage, and that should give me this within margin based on the power factor. So if I take 29 amps times 231 volts, it's definitely not close to 2.8. That's a power factor of probably 0.5. So very often we can have a very bad power factor. So if the voltage sense, so same with our smart meter, if your voltage sense is not the same as the CT input, that can also result in essentially reading out of step, which is reading it at a very bad power factor. So just double check your voltage input. I mean, this should be normally no more than 20% variance. In European countries, I think we're 0.9 most of the time. Africa and those places, sometimes it can be 0.8, depending on the equipment running on the site. But normally no more than 20% variance on the power factor. So then our CTs are correct. We've done the configuration, so everything should be fine. We have all our inverters on ProMate, everything's online and working. Then we can connect it up to the network. So say we can either set a fixed IP address. So if it is a big network, normally you can ask the IT companies to provide an open IP address, all the settings, so you can ask them what they need to input, what you need to input here, and you can put all that information on. The nice thing of having a static IP address is that you can always access it on the customer's network again. So if you do set this up, take a pen or Cokie and write in the cover, you can write down the IP address of the logger. So if you come there in future, you don't have to reset or anything, you just connect to the network and then you can log into the logger via ProMate and configure it. But if that's not an issue, you can also tick DHCP enabled and press set, and that will set it to DHCP. Sometimes this might fail because we are connected statically, and that can sometimes create an interruption. So if that does fail, we'll have to set it manually with that same reset button. So press and hold that for about 3 to 5 seconds, let go, and we should see the left to right as here. If we don't see that, we can press and hold it again for 10 seconds, let go, and then press and hold it again for 3 to 5 seconds and let go. Then we should see the left to right. Thereafter, the server LED should then, well, once you plug it now into the customer's router, then the server LED will come on and be solid. If it is flashing or anything like that, or after a small period of time starts to flash, it could also be the port forwarding issue, especially big companies with firewalls. That can also be an issue. So then you'll have to contact their IT department to do the port forwarding for you. And then we have the next round of questions. The last and final round. Question number 1. For what is the DC power supply an effective tool? Question number 2. What is the cause of utility loss? Question number 3. What is the tool called to configure the EasyLogger Pro? Has a catchy name. Question number 4. What's not true about an isolation fault? That one's a bit of a trick question. And then the last question. To set the EasyLogger to a static IP, we have to press the reset button for how many seconds? So while everyone's finishing up their questions, if anyone has any questions to ask in the Q&A, please feel free to pop them to me. We still continue to do the questionnaire even after we've closed this for at least an hour afterwards. We can just fill out that and finish it. Now please note the installer code for EV Master is GoodWe 2010. That's the installer password. For the installer code or installer account on SAM's portal, you'll find in the registration of the GoodWe Plus webinar, you will find that we have a link there that you can click and then register your account. If you already have an end user SAM's portal account, you'll have to use a different email address to create a different account there. As I said, most of the questions regarding GoodWe Plus you will find in the FAQ of GoodWe Plus. So if you have any questions after the webinar or wondering about your warranty or anything like that, you can find that in our FAQ section. We'll normally, within a week or so of all the GoodWe Plus webinars, so after this one, we'll send out an email to everyone with the presentations as well as the results for the GoodWe Plus. Thereafter, it will take a little bit of time for our teams to enable your status on the back end. And you'll find in the FAQs how to view. Theo did show us in some of the earlier ones on how to view your warranty status on the SAM's portal. Well, thank you very much for everyone for joining. If there is a module that you missed or anything like that, you are welcome to register just for one specific module again. that you can do next time. But if you've done them all now, thank you for joining us. I'm sure we'll have refresher training in the future as well. Then we'll get to see you again. And thank you very much. And thank you for your support.